In mathematics, we have four major operations: adding, subtracting, multiplying, and dividing. There are other things that sometimes occur in problems, like, for instance, exponents, which we'll talk about in a moment real quick, and other things like parentheses and brackets, which act as grouping symbols. So we need to agree amongst everybody for when we see these various symbols inside problems, what do we do first, second, third, and so on and so forth, so that we all get the same results. So this connects to an idea called the order of operations. So before looking at what the order of operations are, let's review what exponents are real quick. So exponents indicate repeated multiplication. So there's going to be a big number and a little number when you have something written in exponential form. The big number is called the base, and the little number, which is written in the upper right-hand corner with respect to that base, that is called the exponent, or sometimes it's called the power. Now, what the exponent tells us is how many times to multiply the base by itself. And there's where exponents indicate the repeated multiplication. So in this example, I have 2 as my base and 3 as my exponent. So this says I want to take 2 and I want to multiply it by itself 3 times. So to simplify this then, you would write it as 2 times 2 times 2, which is 8. So be very careful when you're working with exponents. We recognize that exponents indicate multiplication, and sometimes if we're working too fast on a problem like this, we just take the big number and multiply it by the little number, and we think about this as being 2 times 3, which is not what's going on here. It's not big number times little number. It's big number multiplied by itself, the number of times that the little number tells me to do it. Now, when we have things written in exponential form, there are 2 of them that are said very special. If there's a little 2 up there in the exponent, we can say that is squared. And if there is a little 3 up there in the exponent, we can say that is cubed. And it has connections to geometry and to squares and cubes, looking at their area and volume respectively, right? So we won't get into exactly what that connection is. But those are the ones that are said special. So if I have 5 with a little 2, you can either say that is 5 squared, or you can say it is 5 to the second power. If I have 5 and a little 3 up there, you could say that is 5 cubed, or you can say it is 5 to the third power. Any other exponent that's up there, we would just say to the whatever power. So this with 5 with a little 4, we would say that is 5 raised to the fourth power. And you can also have a 1 up there in the exponent. So that one is kind of a goofy one, because obviously I'm not going to be repeatedly multiplying anything, because this says I only have the base once. So I would verbally say this is 5 raised to the first power, and 5 raised to the first power is actually just 5. All right, this exponent is just telling me I have 1 5 in my multiplication problem. So I really don't even have a multiplication problem, right? The 5 is just sitting there. So what this is showing me is all numbers have an attached exponent on there. If it's a 1, though, we tend to not write it. Later on, depending on what sorts of mathematics that you're doing, sometimes it's helpful to actually put those little 1s in there, because it helps us with computations later on. Now, fun fact with exponents, you can actually have 0 up here, you can have negative numbers up here, you can have fractions up here, and all of those little things that we can do up there in the exponent region of a number have different connections to different areas of mathematics, which is pretty cool. Beyond the scope of what I want to talk about right now, but there can be all sorts of goofy stuff up here in exponent land. But for our purposes right now, we're just going to keep it with these nice kind of simple, easy counting numbers up there. All right, so there's our review of exponents. So let's talk about how that connects to order of operations. All right, so I saw this and I thought it was kind of a funny way to highlight order of operations. So it says on this image right here, 2 plus 2 divided by 2 equals 3. And then there's a caption underneath it. It says confused screaming. All right, so let's talk about why 2 plus 2 divided by 2 is equal to 3. because that looks a little weird. In math, we say that certain symbols are more important than other symbols if they occur inside of the same problem. So the first thing that we want to look at when we're looking at a math expression is grouping symbols, right? So grouping symbols, the most common grouping symbol that's used would be parentheses, but you could also see sometimes brackets, which are just another form of parentheses. Sometimes we'll see multiple parentheses. Those are actually called nested parentheses. But other things can act as a grouping symbol inside of a problem. Some other common examples we're going to see is a fraction bar can act as a grouping symbol. Or if you have like a square root sign and there's like more than one thing underneath there with an operation, then the square root is acting as a grouping symbol, kind of grouping what's underneath there separate from everything else. All right, so if you have something that's a grouping symbol, we want to pay attention to that and pay attention to the group. If there is more than one grouping symbol, you start at the innermost group and you work your way out. Okay, so we'll have a problem where we'll see that. Next thing we want to look at is whether or not there's any exponents in the problem. So usually those are very obvious because you've got those little numbers in the upper right hand corner, but if you have something with an attached exponent on there, you want to evaluate that exponent, which basically just means go ahead and compute whatever that exponent is telling you to do to that base. The next thing we want to look at is multiplying or dividing. But that one's kind of a goofy one because the or is very special. We'll multiply or we'll divide in order from left to right. So if the division actually occurs before the multiplication in the problem, we'll do the division first. So it's not always multiplying before dividing. The dividing could occur before the multiplying. It depends what is happening from left to right. And then finally, if there's anything that needs to be added or subtracted, we will do that. And again, we tend to work from left to right. So if subtraction occurs before addition, we will do the subtraction first. So if we all follow these rules, we will all get to the same results. So let's go back up to this problem right here. So I have 2 plus 2 divided by 2. Now, following the order of operations, I don't have any grouping symbols in here, and I don't have any exponents. So the next thing I would look at is if there's any multiplying or dividing. Now there is dividing in this problem, so we would do the dividing next. The parts that I'm not looking at yet, I'm going to carry down, so I'm not looking at the 2 or the plus yet. But for this dividing part, I'm going to do 2 divided by 2, which is 1. All right, so now I have this 2 and this plus that I hadn't looked at yet, but from the result from the division problem gave me 1, and then 2 plus 1 is 3, right? So that's where they're getting this 3 on this shirt. Some people, when they look at a problem like this, they might want to work through the problem by doing the operations moving from left to right, meaning that they would want to do the 2 plus 2 first, which gives you 4, and then do the division. 4 divided by 2 is 2. But you can obviously see here that we didn't get the same result in both cases. So that's why we have to agree upon the order in which we're going to do operations, so that way we all can look at the exact same initial problem and get the same number at the end. Because we can't have on some days that this thing gives me a 2 and other days this thing gives me a 3. All right, that would be super confusing. So this is not going to be the appropriate way to work through this problem, moving just from left to right and dealing with whatever we happen to see along the way. The order of operations tells me what to look at. So that means you might be bouncing around, looking at different parts of a problem, pulling out what pieces we would want to do first. Now, all scientific calculators and graphing calculators are programmed to follow the order of operations. So if we put this entire thing in our calculator all at once, everybody's calculator would compute the division before it does the addition. If you're using kind of a simpler calculator, maybe sometimes what's called a 4-function calculator, or even like a cell phone calculator. Sometimes, depending on how fancy the programming is, they might not necessarily follow the order of operations. So that's why you've got to be very careful when you're doing these types of computations. All right, so let's do a couple more examples. So in this next one we want to do, we have 36 divided by 6 times 3 plus 5. So we're going to go ahead and throw this order of operations at it. So first we're going to look at grouping symbols, which we don't have any. Then we'll look at if we have any exponents, which we don't have any. So now we're moving into multiplying or dividing in order from left to right. Now remember, it's or dividing. So as I move from left to right, if division occurs before the multiplication, I do the division first. And in this problem, that's exactly what's happening. We're going to do this division first. 36 divided by 6 is 6. And then I'm going to copy down all the pieces that I haven't used yet. All right, so now I'm looking at this new problem, 6 times 3 plus 5. Going back to order of operations, I'm still going to be on my multiplying or dividing step because I still have multiplication in here. So we're going to do this multiplication. 6 times 3 is 18. And I'll carry down the stuff that I haven't used yet, which was that plus 5. Now I'm done with all my multiplying or dividing, so now I'm going to go on to my adding or subtracting step. So then I'm going to do my 18 plus 5, which is 23. Now when you're doing these order of operations, we should notice that as we're working down, each line gets kind of like smaller and smaller. It kind of starts funneling down until at the very end we end up with a single number. All right, so that's how the order of operations work, and that's how it tells us to work through a particular problem. To remember the order of operations, I like to write GEMDAS, G-E-M-D-A-S. Stands for grouping symbols, exponents, multiply, divide, add, and subtract. But to remind myself it's multiplying or divide, I circle the M and the D, and I put an arrow above it, so it's multiply or divide in order from left to right. And same thing with the A and the S. It's add or subtract in order from left to right. So I use that to help myself remember the order of operations. All right, very cool. Let's try some more. This next example, it says 9 times 3 minus 8 divided by 4. Now I want you to notice in the problems that I'm giving, I'm going back and forth between the X for multiplication and the dot. Well, sometimes out there in the world, depending on what your source material is, you might see either symbol used, but moving forward, I tend to use the dot because when we get into algebra, we don't want to have to untrain ourselves. Okay, so there's where this one is going to be using the dot for the multiplication. All right, so I'm going to remind myself about my order of operations, grouping symbols, exponents, multiply and divide from left to right, add and subtract in order from left to right. On this particular problem, I don't have any grouping symbols, no parentheses or anything like that. I also don't have any exponents. All right, so there's nothing on the grouping, nothing on the exponents. So now we'll multiply and divide in order from left to right. We hit this multiplication problem first, so we'll do that. 9 times 3 is 27. And I'll carry down everything else that I haven't used yet. So the minus, the 8, the divided by, and the 4. Throwing order of operations at this again. Again, no grouping symbols, no exponents. I'm still in my multiply and divide step. I have this division right here. This 8 divided by 4 would give me 2. I'm going to carry down these other pieces. So sometimes when you're working through these, you might be able to do maybe sometimes more than one step in the order of operations. So if you were comfortable in this first line, seeing how the multiplication is going to be kind of like one step I have to do, and this division is another step I have to do, we could have skipped this second line and just gone right down to this third line of work, this 27 minus 2. If you're finding that you're not getting the right answer, or you're getting a little confused what's going on with the order of operations and things like that, it's better to go slow. So pick one thing to do and do your one thing, and then carry down everybody else that you haven't used yet, right? That's the best rule of thumb to make sure that you don't goof up order of operations. When you get a little bit more comfortable with it and you get how to like break apart a problem, you might be able to do more than one step at once. All right, so finally on this part, I no longer have any multiplying and dividing, so I'm kind of done with that step. So now I'm on my adding and subtracting. 27 minus 2 is 25. So that's my final answer for this problem. Again, I have this kind of nice little funneling action, each line getting a little simpler. Let's move on to another one. This one will involve some grouping symbols. So it's 2 plus 5 parentheses 7 plus 6 close parentheses. So I'll draw it over here, GEMDAS, to remind myself of my order of operations. Now this one does have a grouping symbol. This set of parentheses is acting as a group to kind of pull that 7 plus 6 away from everybody else. So I'm going to carry down the 2, the plus, the 5, and inside the parentheses I'm going to go ahead and do this addition. So 7 plus 6 is 13 inside the parentheses. Now I've simplified what's going inside those parentheses. At this point in time, these parentheses are no longer a grouping symbol. They're still in the problem because they're still special, but they're not a grouping symbol. And why not? Because there's no operation inside the parentheses. It's just a number, just a 13. Okay, so I don't have these parentheses acting as a grouping symbol anymore, so I have no more grouping symbols in this problem. I also don't have any exponents in this problem, so I'm done with that step. But the parentheses right here end up being important because do we see how the 5 is sitting right next to the parentheses, no operation in between them? That indicates the operation of multiplication, right? When you have numbers sitting next to parentheses, that means we want to multiply them. So I left the parentheses there because I needed to keep some sort of an indicator that the operation that's happening right there is multiplication. So we're going to want to do this multiplication next. So this 2 and this plus, I'm going to just carry it down onto my next line. And then 5 times 13 is 65. So now this multiplication is done. I don't have any more multiplication or division, so I'm done with that step. Now I'm down to my adding and subtracting. 2 plus 65 is 67. So we need to be careful in problems where we have parentheses as a grouping symbol when there is a number sitting right next to the parentheses, because that will also indicate an operation of multiplication that we'll need to account for later on. All right, next problem. 48 divided by 3 times 2 squared. All right, so order of operations. So GEMDAS. On this one, I don't have any grouping symbols, no parentheses or fraction bars or anything like that, but I do have an exponent. Now, exponents always remind me of a Tyrannosaurus Rex. And when I say that is I mean that they have the shortest little arms possible, right? Little tiny arms. They cannot reach out very far. Exponents can only affect what to its immediate lower left. So like what it can reach out and touch. So this exponent right here can only touch that 2. It doesn't get to affect anybody else because it's not that strong. It's got little tiny arms. So this exponent only affects the 2. So the 48, the divided by, and the 3 are all just going to be carried down to my next line. And I'll carry down that multiplication symbol too, because right now I just want to do 2 squared, which is 2 times 2, which is 4. Now remember, this is not little number times big number. This is big number times itself as many times as a little number tells me to keep multiplying it. All right, so now I'm done with my exponent step, yay. Now I'm on to multiplying or dividing. So it's from left to right. So as I look at this problem from left to right, the division actually occurs before the multiplication. So we'll do the division first. So 48 divided by 3 is 16. And we'll carry down the times and we'll carry down the 4. So now that I've done the division, the next step would be this multiplication. So then 16 times 4 is 64. All right, so our first problem with an exponent working through there with the little tiny arms, hopefully not too terrible. Let's take a look at another one that will have all the steps. All right, well, maybe not all of them, but it'll have most of them. All right, so it's 7 plus parentheses 6 minus 2, close the parentheses, and then raised to the second power. All right, so the order of operations says the first thing that I want to look at is my grouping symbols, and on this one I do have grouping symbols. I do have a set of parentheses. It has an operation inside of them. So I would want to simplify this operation inside here. So 6 minus 2 is 4. And I'll keep that inside the parentheses for a moment and then carry down all the other pieces. So the 7 plus the parentheses, I'll put a 4 on the inside, close the parentheses, and then I'll have the little 2 on the outside. This parentheses no longer act as a grouping symbol anymore because there's no operation inside of it. So my grouping symbols are gone. So now I'm on to my exponents. Now this exponent of 2 with the little tiny arms, right now if it would reach out and touch something, what does it touch? It touches the parentheses. So that exponent then affects everybody inside the parentheses. Now at this point in time there's only one little number inside the parentheses, which is the 4. So that exponent then has a base of 4. This gets important later on if you move into like algebraic structures in terms of working with parentheses and exponents and how it affects things. But the key thing is that 2, the way I've it written right now, affects the whatever's inside the parentheses, and at this point in time inside the parentheses is just the 4. Because there's only one number inside the parentheses, if you had wanted to drop the parentheses, you could. But you have to be careful about just getting rid of parentheses unless you know for sure that they are not needed. It's always better to have them and not need them than need them and not have them. Right? So in this case, though, we could, in theory, omit them and have the exponent affect just the 4. Right, so I have 4 squared, which means take 4 and multiply it by itself twice. So 4 squared is 16. And we'll carry down these other pieces that I haven't used yet. All right, so now I have the 7 that I carried down, the plus, and now I have the 16. So now we're on to the last step of order of operations because I'm done with my exponents. There's no multiplying or dividing really on this problem, so I just have the 7 plus 16, which is 23. So there's my final answer for that guy. Okay, so the moral of the story on this problem is if you have an exponent on the outside of a set of a grouping symbol, we have to simplify the group until we get down to a single number, and then we have to be very careful about who that exponent actually affects inside that group, especially as these numbers inside the parentheses might get more complicated. It might be a signed number, a fraction, algebraic structure later on. If that's in your future, you know, whatever the case may be, we have to just be careful there. All right, so in the next example, we're going to get into what are referred to as nested parentheses. So we're going to have a grouping symbol inside of another longer grouping symbol. So let's take a look at this one. All right, so I'm going to again write down my order of operations GEMDAs. That reminds me about what I'm supposed to look at. And for this problem, it's 4 cubed plus bracket. 3 squared minus parentheses, 10 divided by 2, close the parentheses, close the bracket, minus 7 times 3. So as these get longer and more complicated, here's where this acronym helps us. We just take a deep breath, and remember, if you get confused, just do one thing at a time. Now, I have 2 sets of grouping symbols. Right? So I've got the brackets and the parentheses both acting as grouping symbols. So you start at the innermost group and you're going to work your way out. Anything that you're not using, you would just go ahead and copy it down on your next line. So right now I don't want to look at this 4 cubed. I don't want to look at this plus sign. I want to look at this inner group right here. So I'm not even going to look at this 3 squared or this minus sign. I'll carry down the parentheses once I'm done figuring out what's inside there, and then minus the 7 times 3. All of that stuff I don't want to look at yet. I just want to look at this innermost group. So on my innermost group I have 10 divided by 2, which is 5. So that would be inside that set of parentheses. All right, so that's simplifying your innermost group. Now that those parentheses right now don't act as a grouping symbol anymore because there's no more mathematical operation inside of them. So that is not a grouping symbol anymore. So now I would want to move to my next group, which is going to be what the brackets are indicating. Okay, so this is the working out from that innermost group to the outside group. So now I'm really focusing on what's happening inside this group. So this 4 cubed, this plus sign, and then this minus 7 times 3, everything that was outside of that group, I'm not going to look at right now. I just want to look at what's happening inside this group. So inside this group, what do I have? I have 3 that's going to be squared, and then minus, and then the 5. And the 5, there's nobody trying to multiply through because there's no number sitting right next to the parentheses. There's no exponent acting on the 5. So this set of parentheses around the 5 really doesn't need to be there. And again, you don't want to drop the parentheses unless you can assess if it doesn't need to be there. Why doesn't it need to be there again? It doesn't have a multiplier right next to it, and it doesn't have an exponent attached to it. Okay. It's behind subtraction, but since there's only one number inside of the parentheses, we can just get rid of the parentheses and then just do the subtraction. Right, so now I'm still on this innermost group. I haven't really done anything other than remove these parentheses because I don't need them, so they hurt my eyes when they're there and I don't need them. Now in this innermost group, I'm going to throw the order of operations at it. So inside of that group, I would want to do exponents first, then multiply and divide from left to right, then add or subtract from left to right. Because I have that exponent, I'm going to go ahead and do that first. So 3 squared, which is 3 times 3 is 9. Minus 5, close the group, minus 7 times 3. All right, so I'm still on this group because I still have an operation inside of it. All right, so those brackets are still acting as a grouping symbol. So now I'm going to want to do the subtraction inside that group. So 9 minus 5 is 4. And again, I'm going to carry down everything else that I haven't used yet. Now I don't need the brackets anymore at this step, because those brackets are no longer acting as a grouping symbol. There's no more math operation inside of them. And again, I don't have a multiplier trying to come through, sitting right next to the brackets, and I don't have an exponent on the outside of the brackets. So I don't need the brackets anymore, so I dropped them at that step. All right, so no more grouping symbols. Yay. Now I'm going to evaluate any other exponents that are in the problem. Okay, so I've got that 4 raised to the 3rd power. Okay, so 4 times 4 times 4 is 64. And I'm going to carry down everything else that I haven't used yet. So the plus 4 minus 7 times 3. No more exponents. I'm done with that step. Now I'm on my multiplying or dividing. I do have some multiplying over here. So all of these other guys that I don't want to use yet, I'm going to carry down. The 7 times 3 is 21. Now I'm done with my multiplying and dividing step. So now I'm on to my adding and subtracting. And I'm just going to go ahead and do them in order from left to right. 64 plus 4 is 68. And then 68 minus 21 would be 47. All right, so that one was kind of a long one because of the nested parentheses. There is a couple things I could have done earlier. So like, for instance, this 4 cubed out in front, because he didn't really have anybody impacting him. I maybe could have evaluated him sooner. Same thing with this multiplication. But when you're doing order of operations, it's really easy to kind of get tripped up by certain parts of the problem. So that's why it's always a good idea to pick the one thing that you want to evaluate on a particular step, and then just carry down everybody else that you haven't used yet. So that way you don't get too overwhelmed by where you want to look at a particular part in the process. Okay, so that one was an example that had what are called nested parentheses, so like inner groups and outer groups. Last example that I want to look at is a different way to use a grouping symbol. This one will use a fraction bar as a grouping symbol. All right, so there are parentheses technically around the numerator pieces or the top pieces and the bottom pieces that we don't normally write those parentheses, but they are absolutely there. So this bar representing division, I can also think about it as representing a fraction, breaks apart the top pieces from the bottom pieces. So it's grouping them separately from each other. So when I go to work through my order of operations, all right, I will deal with those grouping symbols kind of working both in the top pieces and the bottom pieces separately. So in the top I have 25 plus 8 times 2 minus 3 cubed. And in the bottom pieces I have 2 parentheses 3 minus 2 close the parentheses. All right, so normally on a lot of these problems you can see that I've been working down as I move from one step to the next and trying to keep the source or the new information underneath the source information. All right, so that is a good plan when you're working in math, is we worked top to bottom and left to right. So on a lot of the other problems I've been working kind of from the top to bottom, but this one sometimes because of the this bar, sometimes I would like to work to the right as opposed to working down. So I'm going to move this over to come join this problem. All right, so for my next step, I'm just going to repeat this big long division fraction bar right there. Upstairs, I'm going to throw the group or the order of operations just at the upstairs stuff. So at the upstairs stuff, no grouping symbols up there, but I do have an exponent. So I'm going to do the exponent up there. So I'm going to keep the 25 plus the 8, the times the 2, minus, now I'm just going to evaluate this exponent. So 3 cubed, which is 3 times 3 times 3, is 27. Okay, so that's the one thing that I wanted to do upstairs. Now, the downstairs is being grouped separately from the upstairs, so I'm going to throw the order of operations at the downstairs stuff separately. So downstairs, I do have a grouping symbol inside of that downstairs stuff, so I'm going to do that grouping symbol first. So this 2 in this parentheses that I'll keep, 3 minus 2 is 1. All right, so those parentheses will be needed because the 2 is sitting right next to the parentheses. At this point in time now, that's acting as a multiplication operation. All right, so back upstairs, order of operations. What do I want to do next? I don't have any grouping symbols and I don't have any exponents. So now we'll multiply or divide in order from left to right. I only have that one little multiplication problem in there, so we'll do that next. So I'll have 25 plus, the 8 times 2 is 16, minus 27. Downstairs, I can throw order of operations at that again separately. Downstairs, I don't have any grouping symbols, I don't have any exponents, but I do have that multiplication, so 2 times 1 is 2. All right, so now I've been working to the right. Now I'm going to go down, okay, and carry my next line down here. Sometimes if you think it's going to be really confusing, you can draw an arrow, but otherwise, again, conventions are when we're looking through problems and we're trying to find the next step, because I'm running out of space over here, we're going to go down to looking at the next step and then over to the left as far over as work is written. So upstairs, I don't have any multiplying or dividing, so I'm just going to add or subtract. So 25 plus 16 minus 27 is 14. Downstairs, I just have that 2. Now that I have gotten this down to a single number, both upstairs and downstairs, now finally I can do this division. 14 divided by 2 is 7. So my final answer for this problem is 7. Depending on the type of calculator that you have, this problem is a little bit more challenging to key into your calculator all at once because on some calculators you'll need to put in the extra set of parentheses both upstairs and downstairs before you hit your division symbol right here so that your calculator can better understand the groups that we can visually see on paper. So this is why it's important to have a understanding of order of operations, because your technology is only as smart as what you give it. So if you key this expression into your calculator wrong, not telling it exactly what's kind of going on structurally inside the problem, your calculator could follow the wrong order of operations. It's going to do what you tell it to do. So that's why we like to go into a little bit about what the order of operations are and why we have to do certain things before other things in mathematics, so that we can all agree upon kind of the level of importance on our various operations, and that way we all arrive at the same final answer.